I had a viewer comment on my stuck in the big chainring video, and he had a question that he had switched out his bottom bracket, and now his derailleur wouldn't ship down into the small ring. So kind of made this video to kind of show basically what can happen and how to address it. And typically on a bottom bracket swap, and I'm just going to assume this was it was a square tapered bottom bracket, and I've got just a little dummy assembly here. Just kind of measuring that out, the bottom bracket shell width, and it's 68 millimeters, which is pretty common. And then I kind of did a little measurement there from the edge of the bottom bracket shell to the outside edge of the spindle. So one thing, you always want to kind of measure the overall length of your spindle if you're going to do a bottom bracket swap. So kind of just drew this little, kind of little model of the side view of a crank arm there with the two chain rings, and then there's your crank arm going up. So where this would sit typically would be, maybe just kind of a rough guesstimate somewhere right in here. And typically your front derailleur, it's going to be kind of the opening there is going to, depending on which gear you're in, is going to kind of hover centered over each chain ring there. So if for whatever reason you're to put a little wider spindle, it's going to be out further, so your chain's not going to want to go up to the big ring. If you go with a slightly more narrow spindle, then you'll have this situation where you're not, it may get up into the big ring, but it's not going to drop down into that small ring there. So, and that can happen as well, not just a tapered. If you have a BB30 and maybe put too many spacers on that drive side, it can happen as well. So, anyway, I had this bike in for repair, and I thought it would be, we were doing a bottom bracket swap on it, so I thought it would be a good little example of this particular situation. So this one, obviously the non-drive side cup had, basically the bike had been ridden until that essentially came out, and it kind of ate up the bearings a little bit and the bearing surfaces. I probably could have reused it, but chose not to. Just put a new cartridge in and kind of gathering up some of the tools we're going to use. Got the bottom bracket cartridge tool, and then I got a little socket there, 14 millimeter socket, and then a crank puller. Some of the bolts will use an 8 millimeter and a little Allen bolt there, and then this is the flats for the drive side fixed cup. So this is basically all the tools I'm going to need there on the kind of the side to remove it. Sometimes you'll have a little dust cap there. Sometimes they screw in, sometimes they just pop out. Sometimes you need a screwdriver. I'll usually have a slot or an Allen key if it threads out. So got that out, and then with my 14 millimeter socket here, I'm just gonna undo that, standard counterclockwise direction. And then once we get that bolt out, we can put our crank puller in. Like I say, some of these bolts, they may be an 8 millimeter thread-in bolt with the dust cap built in. That's pretty common. And so you can see just the threaded, it's 14 millimeter socket fits on there. So got our little crank puller tool, and then the large threaded section will just thread right into the outside portion of the crank there. And common mistake I see with these is for kind of the home mechanic is not getting that part tight enough. You want to snug that thing down before you start working basically what that does is it just threads in and pushes against the spindle, and so the threaded portion just grabs hold and pulls the crank right off the spindle there. So you want to make sure that the part that's threaded into the crank arm is threaded in all the way and it's snugged down. So I've seen where if it's not snugged down, it can just pull those threads out of that soft aluminum crank arm there. So just kind of a little close up there of the little threaded portion there. So this one, the non-drive side there was already loose, so this whole thing's just gonna come on out from there. If that was all in there together, you would just do the same procedure for removing the crank arm on the other side. And then this is basically on the non-drive side, you got basically the adjusting cup there, kind of going back to our little dummy bottom bracket shell there. So typically this, you got a little ring that locks it in place. That's our little ring spanner tool. You're going to back that off counterclockwise to loosen it, and then from there, that's the little tool that'll fit that particular style. Sometimes there may be little 6 little holes in there, and you'll need a little ring spanner, or sometimes even just a punch and a hammer can break that loose. And then once it's loose, normally you can just kind of unthread it by hand, unless it's a really older bike. And in that case, it's going to be you'll need something to get in there and grab hold to it a little better. But you can use if you got this style, you can use with that crank arm off, you can use just an adjustable wrench there. This would be the correct tool on that particular one. But some of them, like I say, instead of those flats there, they're going to have a little different method. If you're using this type, putting it back in there, you'll want to just adjust it to where there's no play, and then you lock that ring back down. On the drive side, that's your fixed cup there, so it's always going to be tightened all the way against the frame, and the threads on this side are actually backwards, so we're going to go clockwise there to loosen it. Sometimes I'll smack it with a dead blow there, if it's really stuck in there. And on this particular bike, it's an aluminum bike, so sometimes you got to be careful, especially on bikes where I had that adjusting cup on the other side just work its way out. Sometimes that can damage the threads in the frame. On this one, it didn't really hurt anything. So if it does, sometimes you may have to run a bottom bracket tap there and clean up those threads. Anyway, this is our cartridge bottom bracket that I'm going to replace it with. And as you may not be able to really see it here, but the one we're replacing with the replacement bottom bracket there is slightly narrower, and this is just one that the service writer had picked, and just kind of maybe did a rough measurement on the frame and determined this would be a good size to try. There's actually a size wider. That's a 118, the cartridge, and the actual spindle there was a 122. So typically you would go back with what was in there, which was a 122. I thought I was going to just basically try this one just to see how it worked, because it seemed like the crank was pretty spread far out on the frame. So what I'm doing here is just measuring as far as right where the frame went in to how far out that one sits from that flange to the end of the spindle. And then in measuring this one, you can see it's I don't know, maybe 3 or 4 millimeters further in. So basically what I did was I just kind of mocked it up there. And looking at the set screws, how the previous crank was adjusted, it's adjusted pretty far out. So that's kind of another indication that maybe that spindle was a little on the wide side. So basically I just threaded this one in. Again, that drive side is going to be backwards thread, so counterclockwise to tighten it in. And what I did here was just threaded it in all the way, and I'm just kind of mocking it up and just making sure this is going to work. And I just fit the crank arm there on it, and I just wanted to check to make sure that the crank arm wasn't going to be close to hitting the frame, and then that the chain rings weren't going to, especially that small ring wasn't going to hit the frame. And yeah, we had plenty of clearance on both there, especially the crank arm. It was probably still 2 inches away, which honestly we probably could have gotten away with like a 115 millimeter width spindle. But anyway, check the non-drive side, same story there. Quite a huge gap. I think these cranks were actually probably designed for a mountain type bike. But anyway, so I determined that our bottom bracket was going to work, so I'm just going to go ahead and pull it out here and get everything good and lubed up. I just put some green Park, just general grease here on the just general bearing assembly, whatever, kind of an all around decent grease there, and just put it all on the threads there. And then I like to put it on where the non-drive side cup is going to fit in. It's surprising how much water can get down in these, so a good liberal amount of grease can go a long way into you know, if you ever had to take this thing out again and if it gets rusted and corroded up in there, it can be difficult to get them out. So, you know, these have that the white stuff there that's on the threads, or I think it's kind of a retaining compound, so you may not be able to, you should be able to start that cup in very easily by hand, and it'll get a little hard to turn after that. But what I like to do on these, I'll get the drive side pretty much in there, and then I'll put the non-drive side, I'll thread it in, get it fully engaged over the drive side. I won't get it tight, just most of the way in, then lock down your drive side, and then go back over and lock down the other side. But you always want to make sure that drive side, that flange, is in full contact with the frame and locked down. Sometimes if you lock it down before you put the other side, the non-drive side in, it may, you know, you may have some alignment issues. So I usually like to get them both engaged with each other, and then tighten down the drive side first all the way, then the non-drive side. Here I'm just torquing the you know, the bolt there for the crank arm, just reverse that, and then, you know, sure enough, I went and started going to shift it down, and, you know, got it in the big ring there to start. It went down barely to the middle ring, but then when I go to shift it down to the small ring, and I think this is probably the issue that my viewer had, and, you know, with that being inboard, another 3 millimeters or 4, whatever, it's not, you know, the derailleur, the limit screws just not quite adjusted that far in. Then I don't know if you noticed there, I had quite a bit of slack in the cable, because I think basically it wasn't adjusted very well in the first place, so I didn't even have to mess with any cable tension on this one. Normally you would have to loosen up that cable maybe a little bit, but, you know, I'm just backing off the low limit screw, and you can see as I'm turning it, it's letting the derailleur come inwards, and so just going a little at a time here, taking little bites, and you know, basically what I'm going to do is loosen that till the chain drops down there. So finally got it to drop, and then where that chain passes by the inner plate of the front derailleur, I want to have just a very, you know, right there, I want to have just a little bit of a gap. I don't want it rubbing when it's in the big cog in the rear, just a very slight gap. That's going to get us in the ballpark there where we need to be. You know, typically, like I say, you may have to adjust cable tension a little. Now we're going to adjust it up to the big ring. So I put it in the small cog, and then up in the big ring, you can see on the outside plate of the front derailleur, there's a pretty good gap there. So I'm going to just tighten the high limit screw till we have just a little bit of clearance there, you know, and again, that is in the small cog in the back there. So yeah, and then, you know, just kind of lucked out on the cable tension. I didn't even have to adjust that, so that's essentially it. And you know, hopefully if you have this issue, or you're looking at switching out a cartridge bottom bracket, that you found the video helpful. Feel free to like it. Questions, comments, put them down there in the comments, and yeah, put your dust cap back on and you're good to go. Thanks for watching.